Second law, thermodynamics.
Hello, good day. So today we will gonna learn about the basic concept and statement of second law of thermodynamics. Second law of thermodynamics is defined as heat cannot flow itself from colder body to hotter body. What is the use of this law? One of the use of this law is to determine if the process is spontaneous or non-spontaneous process.
Spontaneous process.
Thermodynamics sense a process that occurs by itself without any help of external agents is a spontaneous process. All naturally occurring process is a spontaneous process or a process which need work to be done. Example in heat process. Heat process is always transferred from hot body to cold body because in natural way always hotter body to colder body because it doesn't naturally from cold to hot. Here are more examples of spontaneous process. Rolling down a stone downhill, melting of ice, burning of your food, and evaporating of water.
Non-spontaneous process.
A non-spontaneous process, on the other hand, will not take place unless it is driven by the continual input of energy from an external source. Unlike to do spontaneous process, non-spontaneous process needs work to be done. Example of non-spontaneous process is freezing water or making an ice because in order for us to make a ice, we need device with the internal input to make the device work and make it possible for the water to be solid. Because in natural way, the process will always from the hotter body to colder body.
Reversible process.
Irreversible process can be brought back into the initial state without making any change in the adjacent surrounding.
Irreversible process.
A reversible process cannot be brought back to the initial state without making any change in the surrounding.
In the first law of thermodynamics, it relates to energy, and now it can neither create nor destroyed. But in the second law of thermodynamics, it relates to entropy. Let's start. So first, we all use letter S to define entropy. Actually, there are several definitions of entropy. But the first one, we can say that entropy is a measure of the amount of energy unavailable to do work. Second, we can also think of it in terms of the measurement of disorder. For example, if you put a block of ice somewhere in the middle of the street, after a while, the block of ice will have been melted because of the influx of energy. You add heat to the block of ice, so it begins to melt.
Hi everyone, I am Siti Asnaira E. Abang. Earlier, they have been discussed to you about the second law of thermodynamics, wherein they have discussed to you about the spontaneous, the non-spontaneous, as well as the entropy, wherein in second law of thermodynamics, it relates in entropy, wherein they define the entropy a measure of energy unavailable to do work, wherein in thermodynamics, we will transfer energy from one to another. Second, we can also think of entropy in terms of a measure of disorder. So now, let's proceed on how to get the change in entropy. So here is the sample problem. Find the increase in entropy of 1 kilogram of ice originally at 0 degrees Celsius that is melted to form water at 0 degrees Celsius. So the formula in entropy, the change in entropy delta S is equal to the transfer heat Q divided by the temperature. So first, let us find the givens. So we have the Q is equal to 334,000 joules, temperature of 0 degrees Celsius that is converted to Kelvin, which is 273.15 Kelvin. So the formula, how do I get the value of the Q is delta Q is equal to the M, which is stand for the mass of the ice, which is 1 kilogram, the latent heat of fusion of ice, which is 334,000 joules per Kelvin. Latent heat of fusion is the energy required to transition of the unit of a substance from solid to liquid. So just simply multiply the mass of the ice, which is 1 kilogram, and the latent heat of fusion of the ice, which is 334,000 joules per kilogram. And when we multiply it, we will get 334,000 joules. So the unit is joules because we canceled out the kilograms. So that is how we get the value or the unit of joules. So now, since we already have the given, we will proceed to the given formula of entropy. So we will just simply distribute the given to the formula. So now we will have the delta S is equal to 334,000 joules divided by 273.15 Kelvin, and when we divide it, we will get the value of 1,222.77 joules per Kelvin. That would be the change in entropy of that ice when it turns into water. So that is how you deal with entropy. I hope that you learned something.
Kelvin Planck statement.
It is impossible for any devices to operate in a thermodynamic cycle and deliver a net energy by work to its surrounding while receiving heat energy from a single reservoir. And this statement needs devices to generate electricity, and there is no engine give us 100% efficiency.
The Kelvin Planck statement is leads to heat engine. Let's proceed to Kelvin Planck statement. When you have a heat engine, you have a low temperature sink. This heat engine is absorbing some heat from the temperature source, and it covers some work outputs. This statement says that there's no such engine which covered equal amount of work output but equal to the amount of heat input. Or we can say that we cannot have any engine possible if the universe has zero rejection. So this flow is not possible at all. Kelvin Planck statement says that you cannot have a heat engine operating that operate between two temperature limit, and it has no heat rejection effect. If no heat rejection effect, so that we cannot have 100% efficiency, that make the flow not possible at all.
We have a problem here. Compute the amount heat rejected to the surrounding per kilowatt of flow. So we have given work or internal input equals 0.5 kilowatt, and Q2 is heat transfer equals 1 kilowatt, and our T2 is negative 15 degrees Celsius. So in converting degree to Kelvin, you have to add 273 plus negative 15 degrees Celsius, which is 273 here is given, and 273 plus negative 15 is equals to 258 Kelvin.
Find the following. First, coefficient or COP of refrigerator. And here's the formula. COP equals Q2 all over W. And Q2 is 1. W is 0.5, which is given. And 1 divided by 0.5 is equals to 2.
Temperature at which heat is rejected. We're gonna find heat rejected. And the COP of refrigerator is given by. Here is the formula. COP equals T2 all over T1 minus T2. COP is equal to 2 equals 258 Kelvin all over T1 minus 258 Kelvin. And we're going to transpose T1 minus 258 Kelvin. So T1 minus 258 Kelvin equals 258 Kelvin all over 2. And we're going to divide 258 Kelvin into 2. So the result is 129. And we're going to transpose negative 258 58 Kelvin into the right. So it will become positive. So 129 plus 258 is equals to 387 Kelvin. And our T1 is 387.
And last, amount of heat rejected to the surroundings per kilowatt of cooling. So we're gonna find heat rejected to the surrounding, which is Q1. So here is the formula. COP is equals to Q2 all over Q1 minus Q2. So 2 is equals 1 all over Q1 minus 1. So we're going to transpose Q1 minus 1. So Q1 minus 1 is equals to 1 all over 2. So we're going to divide 1 divided by 2. So here is the result. Q1 minus 1 equals 0.5. And we're going to transpose again the negative 1. So Q1 equals 0.5 plus 1. So since it is negative, if we're going to transpose it into the right, it will become positive. So Q1 is equals to 1.5, which is the result of 0.5 plus 1.
Clausius statement.
In Clausius' statement, it is impossible for any system in such a way that the sole result would be the energy transfer by heat from a cooler body to a hotter body. So in more simple term, it is impossible for a device that operates in a cycle such that it transfers low temperature body to high temperature without any external input or work applying. So we're going to show you a diagram so that we can understand easily what is Clausius' statement all about.
Clausius statement. This statement deals with the heat pump or energy-consuming devices. Again, it says that there cannot be any device which is working under two temperature limits that can spontaneously or automatically deliver heat from low temperature to high temperature. You need to have some work input, means as per the Clausius statement, your work input cannot be zero. If it is zero, that kind of device is not possible at all. So spontaneous flow of heat from low temperature source to high temperature source is not possible spontaneously. You should have some energy input which is making this a natural flow to take place.
In natural way, high temperature body always stands for heat to a low temperature body, and it is impossible for low temperature body to transfer heat to a high temperature body. So that is the Clausius statement all about. It is giving us the concept of refrigerator, which is the colder body or the low temperature body transfer heat to the high temperature. And without any work input or work applying, this whole process will be impossible.
So again, the Kelvin-Planck statement and Clausius statement is a two kind of statement of second thermodynamics law. The difference of these two is the Kelvin-Planck statement is a heat engine, while the Clausius statement is heat pump or refrigerator or any consuming device.
Question. Is melting of a block of ice is reversible or irreversible process, and why? Romelyn Caceres and Nara Abang Michaela Gulanarina Kasim Hayat Campbell Jomar Abdul Razak Raymond Tehran Mahana Ashak